Hello everyone. Today's topic is sequential circuits and we will talk about the triggering of flip-flops. My name is Shivcharan Puri, Assistant Professor, EC Department, Asansol Union College. Now, triggering of flip-flops. What exactly it is? The momentary change in clock input of flip-flop to switch it from one state to other is called trigger. And the transition it causes is said to trigger the flip-flop. The process of applying the clock signal to change the state of a flip-flop is called triggering. There are two types of triggering the flip-flop: level triggering and edge triggering. Now what exactly are they? So first of all, we will talk of the level triggering of flip-flops. So in level triggering, the input signals affects the flip-flop only when the clock is at logic 1 level. Okay. Such type of flip-flop is known as level triggered flip-flops. In a level triggered flip-flop, the output responds to the data present as the input during the time the clock pulse level is high. Okay. So when the clock pulse level is high, then only the output will respond. That is, any changes at the input during the time the clock is active or high are reflected at the output as per its truth table. Okay. Since the flip-flop changes its states only when clock pulse is high, this is also referred to as positive level triggered flip-flop. Whereas flip-flop in which state is changed when clock pulse is low is called a negative level triggered flip-flop. Now level triggering of flip-flop will be as explained. As you can see here, this is the clock. So when the circuit will respond, okay, or when the flip-flop will excite itself with respect to the clock is this. When the clock will be at positive level, so this is the positive level clock, then only it will excite itself, or the output or the response of the output will be seen. We can also set the flip-flop to respond at the negative levels, which is called negative level triggering of flip-flop. Now moving to edge triggering of flip-flops. So the clock changes states from 0 to 1 or 1 to 0 as shown in the figure. The figure will be shown. Okay. And we know this. The clock changes its state from 0 to 1 and 1 to 0. But what exactly is edge triggering will be, which I am going to say. The change of state from 0 to 1 is known as positive edge. Okay. So the change of state from 0 to 1 is known as this edge, is a positive edge. And the change of state from 1 to 0 is a negative edge. That was is written over here. In edge triggering, the input signal affect the flip-flop only if they are present at the positive going or negative going edge of the clock pulse. The flip-flop that responds for the positive edge is known as positive edge triggered flip-flop. Okay, which respond to the positive edge. Whereas the flip-flop that responds to the negative edge is known as negative edge triggered flip-flop. That is the negative edge. So edge triggering of flip-flop, you can see here, this is the clock. Okay, and this is the positive edge. As you can see here, it goes from 0 to 1. Okay, so this is the positive edge triggering. Okay. Sometimes it is also known as leading edge. Okay, so this is the positive level triggering of flip-flop. Whereas you can see here, this is the clock, the same clock, and this is the negative level. This is, you can see here, negative edge triggering. It will go from 1 to 0. So this is the trailing end or the negative edge triggering of the flip-flop. the logic symbol of edge triggered flip-flop. As you can see here, either it can be positive edge triggering, as you can see here, but when we put a bubble over here, we get a negative edge triggering over here. Okay. Now this, what is said, why I have considered it a JK flip-flop here. The race around condition is a major problem in JK flip-flop, which we discussed. Okay. And we have also seen that to overcome this problem, edge triggered circuit can be used whose output is determined by the edge instead of the level of the clock signal. So what happened is that when we talk of edge, we either are talking of the positive edge triggering or the negative edge triggering. So this output will change only at this instant of time or this instant of time. Okay. Whereas in case of, what was happened that the race around condition was there because we are getting, the circuit was excited for the whole of the clock. Okay. The circuit was excited for the whole of the clock. So one condition where it can be eliminated can be used by using a edge triggering. Okay. Level triggered flip-flop. As you can see here, we can also go for this configuration. Now the master is set according to J and K while the clock is high. The content of the master, as I told you in the previous class, it will just be shifted to the slave. That is Q changes state when the clock goes low. Okay. This particular flip-flop might be referred to as pulse triggered to distinguish it from edge triggered flip-flop previously discussed. Okay. Why pulse triggered? Because you can see here, this will respond for the positive pulse of the clock, whereas this will respond for the negative response of the clock. So it behaves somewhat like a pulse triggered flip-flop. The master is clocked in the normal way, but the inverted clock is applied to slave. That is, the master is positive level triggered and the slave is negative level triggered. Thank you.